Yo, 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 we're back here with section 2 with Math with Zord, and we'll be solving systems this time. We'll be solving them by graphing, okay? And as we said in section 1, each system can have one solution, no solutions, or infinite solutions, okay? So we have to decide, or we have to learn and decide how we can go about knowing how many solutions we have. Okay, so we can take a look at this little chart, and we'll be able to know how many solutions we have. So if we have a graph where our two lines intersect, something like this, right there is our solution. Okay, we'll have one solution. That point gives us an x value and a y value, and those two are going to be our solution. If we have a graph that looks something like this, where the two lines run parallel to each other and they never cross, that means they have no solutions. And in the last one, there's going to be some times where when you graph both lines, they turn out to be the exact same line. When that happens, that means we have infinite solutions. Okay? So by using this chart, graph each line, and then you're going to know which type of solution you have. Okay? Now the one downside to graphing to be able to solve systems is that when they intersect, it's not always easy to tell where that intersection point is. Like right now with this, as we look at that point, see if I can get the marker to work. There it is. When we look at that point, we can't tell where that's at. Even if you do it on exact graph paper, sometimes it's tough to tell. Okay? So that's the downside. The plus side is it's pretty quick and simple. Okay? The steps, first we need to make sure that we have both equations in slope-intercept form. Then you graph each equation. Then you can use the chart above to determine which type of solution you have. Okay? So as I said, the downside is that you can't always tell exactly what your solution is going to be. And really the best way and the only time you're really ever going to use graphing is if both equations are in slope-intercept form already. Okay? So as we look here at our first example, we can see both equations are already in slope-intercept form. Here we have a slope of -1/1 and a y-intercept of 8. The bottom equation, we have a slope of 4/1 and a y-intercept of -7. Okay? So let's take a look at the graph for these two. We'll put the first one up, the first. So we'll go up 8, 2, 3, 4, 5, 6, 7, 8 for our y-intercept. Then it's telling me to go down 1 and right 1. And there's my line. Okay? If I do the second equation, it's telling me to go down 7, 2, 3, 4, 5, 6, 7, y-intercept. And then I'm up 4, 1, 2, 3, 4 over 1. And there's this line. Okay? Now, here's what I'm going to say, because as you can tell, it's going to be very difficult to mark in little hash marks to decide where my lines intersect. So when we're graphing equations, all I'm going to ask from you is when they intersect, just circle that that's where your solution is going to be and say that you have one solution. Say one solution at the intersection. Okay? Because if you need an exact answer, you're not going to use this method anyways. This is a method of just estimating, trying to determine how many solutions you're going to have. So I'm not going to make you try to count lines and keep your graphs that precise to find out the exact x and y value. If you needed the x and y value to be precise, you would solve this by either elimination or substitution, because they will always give you exact answers, and there's never any guessing. Okay? So that's an example. Both equations were in slope-intercept form. The lines intersect, so we knew we had one solution. If we flip over to the back, we can take a look at two other examples. Okay. The first example here, x plus 2y equals 5 and 2x plus 4y equals 2. The first thing we need to do is get them both into slope-intercept form. So I'll subtract x. 2y is equal to negative x plus 5, divide by 2, and y is equal to negative 1/2 x plus 5 halves. Okay. My second equation, 2x plus 4y is equal to 2. Again, I need slope-intercept form, so I solve for y, which we should be very good at by now. We've done this enough. Divide by 4 to get y equals, I'm going to simplify here. 2 over 4, negative 2 over 4 simplifies to negative 1/2, and positive 2 over 4 simplified to positive 1/2. Okay? Now, let's think about this before I go to graph and use my knowledge of slope-intercept form. Here, I have a slope of negative 1/2. Here, I have a slope of negative 1/2. What kind of lines have the same slope? Parallel lines. Okay? Parallel lines have the same slope. And what was the picture on the front that had parallel lines? No solution. So right away, as soon as we see that we have parallel lines, we can say no solution. Almost right away. Okay? What we'll also notice here is that the y-intercepts are different. Okay? So anytime I have parallel lines, meaning I have the same slope, and different y-intercepts, I have no solutions. Okay? So you don't even need to graph it. Test, quiz, homework, nothing. As soon as you see same slope, different intercept, you know it's no solution because you have parallel lines and they'll never cross. So if I look at this bottom example, I have 2x plus 2y. That was my phone again, if anybody heard that one. 2x plus 2y equals negative 8 minus 2x. Guess I'm just the popular guy tonight. You guys know I'm that cool. Got people calling me all the time. So divide everything by 2, and y equals negative x minus 4. Now take a look at this. Same slope. My slope is negative 1 in both cases. And I have the same y-intercept. Okay? So when I have the same slope and same y-intercept, I'm going to have infinite solutions for all real numbers. Okay, I have the exact same line, y equals negative x minus 4, y equals negative x minus 4. Since they're the same line, if you were to graph them, you would just have one line, which means all real numbers. Okay? So hope you understand that. Hope this helps you with the practice that we'll be doing in class. And we'll see you back here with section 3, talking about either eliminating or substitution. I don't remember which one it is. I think it's substitution. So good luck. Bon voyage.